to talk about an important theorem in calculus. It's called Rolle's theorem. So with theorems, remember, we generally will always have an if statement and a then statement. So in this case, we actually have three ifs. So we are supposing that we have a function that satisfies these three things. It needs to be continuous, it needs to be differentiable, and it needs to have two endpoints that are equal to each other. If all those things are true, then we have a number such that our derivative is equal to 0. So here's a quick little example where you could just see the picture. So let's take a look at this function. I'll call it f. You'll notice, first of all, this one's continuous, and it has no crazy cusps or corners or any vertical tangent lines. So therefore, that means that it is differentiable all over a to b. The other thing is that f of a equals f of b. We can see that they're at approximately the same y value. So what that means is that we have a number such that f prime of c equals 0. Remember, if f prime of c equals 0, that means that we have a horizontal tangent line. So we can look at our graph and we'll notice that it's probably somewhere around here. We do have a horizontal tangent line there. So the c is that value. And actually, any case where you have all three of those things satisfied, you will have a horizontal tangent line, meaning that you're going to have a c value where if you take the derivative at that value, you get 0. For our first example, we have a function f of x equals x to the fourth minus 2x squared. We would like to know all values of c in the interval -2 to 2 such that f prime of c is equal to 0. So we are going to use Rolle's theorem. Whenever we use a theorem, it is very important that we check that all conditions apply. So first of all, we know that because it's a polynomial, we know that f of x is continuous and differentiable on that interval. So we're off to a good start. Please make sure, by the way, that you actually write out that it's continuous and differentiable. Don't just write the word continuous or the word differentiable. I recommend writing a sentence like this. So that's the first thing. The second thing that we need to check is we need to make sure that f of -2 and f of 2 are equal. So you can go ahead and plug those in. You will find that both of those values are going to give you the same thing, which I believe is 8. So we've checked out the first things. We've checked out continuous, we checked out differentiable, and then we also know that f of -2 is equal to f of 2. So we're good to go on Rolle's theorem. You can even write, use Rolle's theorem. Just make sure that if you actually, if you do all of this stuff, you write the right theorem. We're going to learn a few more in this class. So once we've done that, all we need to do now is we actually have to figure out where is that derivative equal to 0. We get 4x cubed minus 4x for our derivative. If we set that equal to 0, we can factor out a GCF. And when you do that, you'll get x equals 0, x equals 1, and x equals -1. Our second example has a differentiable function, and they actually don't give us the function, but they do give us a table. And then they ask, must there be a value c such that f prime of c equals 0? And explain your reasoning. This is actually a really common way for them to ask questions on the AP exam. So the important thing on this is to notice that they're asking you about Rolle's theorem, which I think is the hardest thing on that. If you notice they're asking you about Rolle's theorem, then all you need to go ahead and do is check your conditions and just make sure that it applies. So we are going to look at our conditions. And by the way, the answer is yes. I'll explain why in just a minute. So the answer is yes, because, okay, so now you have to think back about all of your conditions. You have 3 conditions. We need continuity continuity, we need differentiable. So first of all, we know that f is differentiable. They tell us that. Don't overthink on that type of thing. Usually, if you have a function, then they give you a table, they'll actually tell you it's differentiable. And then we also know that it is continuous, since it's differentiable. If you have a differentiable function, we automatically have continuity also there. So yes, because f is differentiable and continuous. The other thing that we need, remember, is we need endpoints where you have something like f of a is equal to f of b. So in this case, if you look at our two endpoints at x equals 1 and x equals 8, those are actually not equal. So we can't do it with a equals 1 and a equals 8. However, if you notice that when x is 1 and x is 4, we have the same f value. It is going to be, that means that our c value is actually going to appear between 1 and 4. So it will be satisfied. So f is differentiable, f is continuous, and we know that f of 1 equals f of 4, which is negative. Both of them are equal to -2. And there's a lot of things that you can say next. I'm going to say, therefore, by Rolle's theorem, we know that there is a C, and I'm going to say that C is between 1 and 4. That's really important that you think about what are your endpoints there. So there is a C where C is between 1 and 4, such that f prime of C equals 0.